Okay, welcome back to our video today. We are still in chapter 13, Business Math 1105, Sultan Qaboos University. And we're going to talk today about finding the maximum and the minimum values of a given function using the second derivative test. So far, we've been using the first derivative test in the previous videos. Now we want to use the second derivative test. The second derivative test, suppose we have a value a for which the first derivative is equal to 0. Then we test the sign of the second derivative at a. And we have two cases. If f double prime of a is greater than 0, at such x equal to a, at such a, f has a relative minimum, where f minimum is equal to f of a. The other case, if the second derivative at the point a, at xa equals to a, is less than 0. In such case, we say that the function f has a relative maximum at x equal to a. And we find the maximum of the function is equal to f of a. So there is also a third case where the second derivative at a is equal to 0. And in such case, we say we cannot use the second derivative test to find the extreme value of the function or the extrema of the function, and we say in such case that at x equals a, the second derivative test fails. And we have to use the first derivative test. Example, use the second derivative test to find the extrema of y equals 18x minus 2 over 3x cubed. Here, we should find the first derivative of the function, y prime equals 18 minus 2 over 3. 3x squared is the derivative of x cubed. Now we can cancel this 3 with the 3 in the denominator. So we have y prime equals 18 minus 2x squared. Now, this is the first derivative. I need to find the values of x for which y prime equals 0. So I take 18 minus 2x squared and I put it equal to 0. We get 9 minus x squared equals to 0. This implies that either x equals 3 or minus 3. So we have two values to study. The second derivative at x equals 3 and x equals to minus 3. Okay, so next step, we find from here the second derivative of y. Y prime is 18, so y double prime is equal to, what's the derivative of 18? 0, minus 2. Derivative of x squared is 2x. 2 times 2 is 4x. So this is the y double prime. So we should start studying what happens if x equals 3. If at x equals 3, this implies that y double prime evaluated at x equals 3 is equal to minus 4 times 3, which is minus 12, less than 0. Less than 0 tells us that at x equals 3, y has a maximum relative maximum. Okay, and we can calculate the maximum value if we wish by taking the 3, going back to the original function and substituting. So y maximum equals 18 times 3 minus 2 over 3 into 3 cubed, and with a little of calculations you can find the maximum value. Okay, go ahead and calculate it. Next, I take the other value of x, which is the minus 3. At x equals minus 3, y double prime, we evaluated that x equals minus 3 is equal to minus 4 into minus 3. So this is 12. 12 is greater than 0. Therefore, at x equals minus 3, y has a relative minimum. And the minimum value will be y minimum, again, 18 times minus 3 minus 2 over 3 times minus 3 all cubed, and you go ahead and find the minimum value. Let's take another example. Let's take another example. Again, use the second derivative test to find the relative extrema of the function y equals x cubed minus 3x squared minus 9x plus 5 on the interval, and they are specifying an interval for us which is minus infinity to plus infinity. Again, we will do the same steps we've done in the previous problem. We should find the first derivative and then the zeros of the first derivative. So y prime equals 3x squared minus 6x minus 9, and the derivative of the 5 is 0. Next, y prime equals 0 implies that 3x squared minus 6x minus 9 equals 0. Divide both sides by 3, I get x squared minus 2x minus 3 equals 0. Now we can factor this. We have x minus 3, x plus 1 equal to 0. So we have either x equals 3 or x equals to minus 1. Okay, we are specifying the interval we are working on from 0 to infinity. This does not belong to the interval given to us. Okay, it doesn't belong to the interval from 0 to infinity. Now we take the 3 and we start studying the second derivative test at x equals to 3. Now, what's the second derivative? Y prime is 3x squared minus 6x minus 9. So y double prime equals 6x minus 6. Derivative of 3x squared is 6x. Derivative of minus 6x is minus 6. And the derivative of minus 9 is 0. Now, at x equals 3, y double prime evaluated at x equals 3 is equal to 6 times 3 minus 6. So this is 18 minus 6. This is greater than 0. Therefore, at x equals 3, y has a maximum value, has a maximum. In fact, it's not a relative maximum because it's the only value on the given interval. There is no other, so we can call it even absolute maximum. Okay, thank you very much. Finally, in this video, I'm going to give you an example where, suppose we're given the demand equation P equals 80 minus Q divided by 4, where Q is the quantity of an item produced, and we are given that it is ranging from, of course, 0 to 80. Okay? We want to find the value of Q for which the revenue is maximum. This is one. Also, we want to find what is the maximum revenue. Okay, so we start our solution recalling that revenue is equal to price times quantity. So in our case, revenue is equal to 80 minus Q over 4 multiplied by Q. Stop. Okay. ونكمل. So revenue equals 80Q minus Q squared divided by 4. We want to find the first derivative, so R prime of Q equals 80. This is the 1 over 4, it's constant, and here I have 80 minus 2Q. So putting R prime of Q equal to 0 implies that Q equals 40. In fact, if you take this, put it equal to 0, you will have 80 equals 2Q, so Q is equal to 40. So can we say that this is maximum or minimum? Unless you apply either the first or the second derivative test, you cannot decide and say immediately that this is a maximum, this is the Q at which the function will have maximum or minimum. So let's go back again and do it with the first derivative test. I put Q equals 40. I know my limit is up to 80, and starting from 0, because it's a quantity, it cannot be negative, it cannot be less than 0. And now we see what's the sign of the first derivative to the left and right of 40. Let's take something less than 40. Let's take 20. So here I have 1 over 4 times a bracket. 80 minus 2 times 20 is 40. If I take 10, 80 times minus 2 times 10, so still the sign here is positive. So the function is increasing in this part because the first derivative is greater than 0. Now, to the right of Q, let's take 50, 60. So here I have 80 minus 2 times 50, it's minus. So here I have 1/4 times a minus sign tells us that the first derivative here is less than 0. And when the first derivative is less than 0, what happens? The function is decreasing. So let's see. I have the first derivative here is greater than 0 because it's positive everywhere in this interval. And then I take this first derivative and I find that it is less than 0 here. So the function is increasing and then decreasing, then definitely you reached a maximum. So at Q equals 40, the revenue is maximum. This was the first part. The second part is asking you to find the maximum revenue. So R maximum is equal to R of 40. Go to the revenue function, remove every Q and put 40. So here I have the 4 in the denominator. I have 80, and this is the 40 minus 40 squared, and we can simply find the maximum revenue by simple calculations. Here you have 4 in the denominator, and up here you have 3,200 minus 1,600, and you simply find the maximum revenue. You calculate it on your own. Thank you. Finally, we will end our chapter 13 discussion on in chapter 13. Stop. شيل الكلمة دي خالص. وهنبدأ يا مصطفى بعد شوية آخر كلام في هذا الباب. Last but not least, I would like to discuss with you in chapter 13 absolute extrema on closed intervals. Okay, simply we will be talking about the extreme value theorem. We will just take the statement of this theorem. So this says a continuous function. Let's look here, and I'll draw any continuous function. Let's say this. This is y equals f of x. On a closed interval, or let's say a continuous function attains both maximum and minimum values on a closed interval. So if I have a closed interval here, for instance, and this is A, and this is B. So this continuous function, it will attain both its minimum and maximum values on this closed interval. Let's take an example on this. For instance, suppose we have the function y equals, or f of x equals x squared minus 4x plus 5. And we are asked to find the absolute extrema of this function on the closed interval 1 and 4. So the first step to solve this problem is we find the first derivative, and then we find the critical values for this continuous function. So y prime equals 2x minus 4. Derivative of x squared is 2x. Derivative of minus 4x is minus 4. Now, taking y prime equal to 0, this implies that x is equal to 2. Of course, x is equal to 2 is in the interval given to us. We can see it is in the interval from 1 to 4. So the second step we will do after having the x equal to, we will evaluate f of 2 and f of 1 and f of 4. So we will find the value of the function f at 1. So I have 1 squared minus 4 times 1 plus 5. 1 squared is 1, plus 5 is 6, 6 minus 4 is 2. Next, I will find f of 4, the other end. So it is equal to 4 squared minus 4 times 4 plus 5. 4 squared minus 4 times 4 plus 5. Can we see that this and this, they add up to 0, so we are left with 5. Now we will find the value of the function at 2. What is f of 2? It is 2 squared minus 4 times 2 plus 5. 2 squared is 4 plus 5 is 9. 9 take away 4 times 2 is 9, take away 8, so the answer is 1. And we come and see what's the smallest value, what's the lowest value of the three, this one, so we have absolute minimum here. What's the largest value? This one, so we have absolute maximum here. And that's it. Thank you very much.